Let's solve few problems based on implicit functions. Look at these problems. Find dy by dx in the following. So all of it, you just have to find dy by dx. All right. Let's start with the first one. See the first one. 2x plus 3y is equal to sin x. Very simple, very direct. So we can write this as 2, you're differentiating, right? Plus 3y dash is equal to cos x. So 3y dash is equal to cos x minus 2. So y dash is equal to cos x minus 2 divided by 3. So this is going to become the final answer. That's all. Very easy, very direct. Understood? Let's start with the second problem. All right. See the second problem. 2x plus 3y is equal to sin y. Again, let's differentiate with respect to x. You get 2 plus 3y dash cos y into y dash. Remember, this is like a chain rule. Okay, so that meaning first sine is the first function, y is the second function. First you differentiate sine, then you differentiate y. Okay, now y dash should be everywhere, the y dash should be the same, like in the sense, take all the y dash on one side. So 2 is equal to cos y into y dash minus 3y dash, correct? So 2 is equal to y dash into cos y minus 3. So what do you get then? Y dash is equal to 2 divided by cos y minus 3. So this is going to give us the second one answer, where we are isolating y dash and we are getting the value of y dash. Make sense? Let's do the third one. For the third one, what you have is ax plus by square is equal to cos y, right? Now again differentiate a, because a into x becomes 1 anyway, a plus b into 2y into y dash. Y square derivative would be 2y into dy by dx. Correct? Here also we are actually, if you look at it, we are applying chain rule here, isn't it? So 2y into y dash is equal to minus sin y into y dash. Derivative of cos is minus sin. So minus sin y into y dash. Now what do you get? A plus 2by into y dash minus sin y into y dash. See, now what we'll do is, we'll take the minus sin y this side and we are going to take the a this side. Transpose. Now when you transpose, you'll get 2by into y dash plus sin y into y dash. So this value is equal to minus a. Correct? So take y dash common. Y dash into 2by plus sin y is equal to minus a. Right? So y dash is minus a divided by 2by plus sin y. So we have isolated, this is going to be the value of y dash. So y dash is minus a divided by this. Clear? Now if you look at these three, the first three are very direct. Just apply, get the answer and done. You're done with it. Alright. Now let's do the fourth one, a little more challenging compared to the first three. Let's do the fourth one. Now in the fourth one, xy plus y square is equal to tan x plus y, isn't it? So what do we do? Start from the LHS. Now, if you want, you can take the Y, which is on the RHS, to the LHS. It's gonna make things a little more easier for you. That's all. All right. See, we can do xy plus y square minus y is equal to tan x. Now differentiate. Differentiate with respect to x. So you will get, first, it's a product rule, correct? Xy, you're differentiating product rule. So when you apply product rule, you will get y plus x into y dash, product rule, plus 2y into y dash, next minus y dash, isn't it? Is equal to secant square x, right? If you look at the LHS, almost everywhere you have y dash common, except for one term, which is just y, correct? So keep that y as it is. Take y dash common, y dash into x plus 2y minus 1, isn't it? Is equal to secant square x. First, what you do is you can take this y dash this side. Do not just divide by x plus 2y minus 1. Guys, mathematically that's incorrect. First, take the y that side. So you will have y dash into x plus 2y minus 1 is secant square x minus y. Now you can divide because y dash is isolated, isn't it? Now if you divide, you will get the answer as y dash is equal to secant square x minus y divided by x plus 2y minus 1. So this is going to give us the answer for this particular question. Remember how we did the problem. First, take the y, then differentiate. You have to apply the product rule. Once you get the y dash, isolate the y dash, like make y dash as the subject of formula. Once you make y dash as the subject of formula, then you can do the division, addition, whatever you want. Are you all clear? Let's do the next fifth question. See the fifth one. What we have, it's again an algebraic function. So you have x square plus xy plus y square is equal to 100, right? Differentiate. 2x, x square derivative, plus here you will have y plus x into y dash, correct? Plus 2y into y dash is equal to 0. Derivative of 100 is 0. Now what do? Isolate the y dash. Basically group here. Take y dash common. And the other two, that is these two, you can just put these two on the other side. Correct? So when you do it, you will get y dash into x plus 2y is equal to minus of 2x plus y. Correct? So what is y dash? Minus of 2x plus y divided by x plus 2y. So this is going to give me the answer for the y dash or the derivative for the fifth question. Clear? Let's do the sixth one now. For the sixth one, if you look at it, sine square y plus cos xy is equal to k. See, generally for constants, we use the symbol k, isn't it? Now, sine square y. Here you have to apply chain rule. That's what I was telling you in the beginning and even in all the videos. Chain rule is extremely important. Okay, very important because almost every problem that requires chain rule to go ahead. So here also when you have sine square y, so what we are going to do, so 2 Sine square, correct? So you can think of it like this. Imagine you have u square. U square will be 2u du by dx, correct? Likewise, here what do we have? Sine square y. Or you can also write this as sine y whole square. Both are one and the same. You'll get this as 2 sine y, the first part, into derivative of sine cos y into y dash. Alright, you might be thinking, how do I get 2 sine y cos y here? Normal differentiation. That means when you have sine square x, this is nothing but sine x whole square. That means you'll get 2 sine x. First part. The next is what? You're going to have to do differentiation of sine, which is basically cos x. So 2 sine x cos x, this is for sine square x. Here what do we have? We have sine square y here. So first 2 sine y cos y, then derivative of y, which is y dash. Correct? Now let's go to the second term. Let's understand how we apply the chain rule for this one. See, what do we have? Cos of xy, correct? So first cos function minus sine xy. Cos is negative sign, right? And then into xy, the product of the two variables x into y. X into y would be what? So you're going to get y plus x y dash is equal to 0. Derivative of a constant is 0. So now what do we have? 2 sine y cos y. You can write it in terms of sine 2 theta because it's a multiple angle. So you're going to get sine 2y into y dash. Please multiply. Multiply, that means you're going to apply the distributive property. Okay, you can do that. Or if you want, you can take it to the other side, but you have to simplify. That's the main point. So you can write this as minus y into sine xy minus x into y dash into sine xy. This is equal to 0. Correct? Now you have to take y dash, y dash. These two terms together. Then the middle term is going to go towards this side. Correct? So take y dash common. So y dash into sine 2y minus x into sine xy. This is equal to y into sine of xy. Now what do we do? You take the y dash, the rest of it you are going to put it to the denominator. Correct? That's what we were doing in all these cases. So what you will get, the final answer would be y into sine xy divided by sine 2y minus x sine xy. Isn't it? Let's write it down. You have y dash is equal to y sine xy divided by sine 2y minus x sine xy. This is going to give us the final value of y dash. Alright, so this is the answer for the given question. Fair enough? Now let's do the 7th question. Alright? Now let's solve the 7th one. See, 7th one you have sine square x plus cos square y is equal to 1. Right? Now differentiate 2 sine x into cos x plus 2 cos y into minus sine y into y dash is equal to 0. Right? Now what you do, you take this term to RHS. Take the term. So you will have sine 2x is equal to 2 sine y cos y into y dash. Because when you take this term to the RHS, it's going to become positive, right? Now what do you have? Sine 2x sine 2y into y dash. 2 sine y cos y sine 2y, correct? So what is y dash? Sine 2x divided by sine 2y. So this is going to give us the answer for the 7th question. All right. Now let's do the last one. See the 8th one. X cube plus x square y xy square plus y cube is equal to 81. Correct? Differentiate 3x square plus 2x into y plus x square y dash plus y square plus x into 2y into y dash 3y square into y dash is equal to 0. See how we are differentiating separately, correct? Now what do? Take all the y dash. This is 1, this is going to be 1, this is going to be 1, correct? The others segregate. So 3x square plus 2xy plus y square plus y dash into x square plus 2xy plus 3y square is equal to 0. Take these things on the other side. That's y dash into x square plus 2xy plus 3y square is equal to minus of 3x square plus 2xy plus y square. So what is y dash? Minus of 3x square plus 2xy plus y square divided by x square plus 2xy plus 3y square. So this is going to give us the answer for the 8th one. All right. Now, so far we have solved around 8 problems in implicit functions. You can solve more. All right. I recommend you solving more problems. In the next video, we'll start with a different type of function.